Welcome to Spring LIB.
Okay, so we've got the following two cyclohexane chairs. And the question is, are these stereoisomers, constitutional isomers, different conformations, or the same conformation of a compound? So I think what will help here is if we can draw in the hydrogen substituents. This would be axial, this one would be axial. And here we can say this one would be axial, and this one would be axial. Okay, now we know then that these two carbons, these two methyl groups, are cis, and these two methyl groups are also cis, right? These are both below the ring, both of these are above the ring in this case, which tells me that if we were to, say, flip this chair over, not do a chair flip, but simply, or do a chair flip, wouldn't really matter. The point is that we would still have that both of the carbons are on the same base of the cyclohexane, and in this case, if we were to flip the chair physically over, the carbons would be on the underside of the ring, whereas now they're in the upper side of the ring. Right? So we can get from this right-hand molecule to the left-hand molecule without reorganizing any bonds, without breaking any bonds. Right? So this makes them conformers, or yes, they're conformers, but are they the same exact conformer simply flipped upside down, or are they actually a different conformer? Well, note that this is equatorial, and this is equatorial, this is equatorial, and this is equatorial. So in fact, to get from one to the other, like I said, all you'd have to do is literally turn the chair over. You wouldn't have to do a chair flip. So they're not conformers in that sense. They're really just the same molecule, but viewed from a different point of view. Okay, let's look at the next example. All right, once again, we have a couple of substituents that are two carbons apart from each other, or two bonds apart from each other. I think it'll help to draw in the hydrogens on each of these. And if I do so, we can start to see that, okay, these bromines are equatorial, whereas these two are axial. Okay. I will also notice that these bromines are cis to each other, and so are these. Right, so we know there hasn't been any stereoisomerism or constitutional isomerism, because they're still two bonds apart from each other, and there's still, four bonds apart from each other, two carbons apart from each other, and they're both on the same side of the ring in both cases. But since we've changed from equatorial to axial, going from one representation to the other, these would have to be different conformations.